Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Got something a little different for you here today. I'm going to actually show you a repair job that I'm doing here in the shop, and it is on a 1977 CB750F Honda. It is the aluminum side casting. I sheared off a couple of locating lugs for the main foot pegs, and you don't want those things rotating out of position if you're trying to get down the road with any kind of, just had a giant, like that big grasshopper fly in. Anyway, the casting cracked, the foot peg can rotate out of position, and this is not something I want to have happen. So I'm going to take a quick look at the bike, quick look at the part, and we're just going to get on with the fix. Hang in. Alright, this is the area right here behind the clutch cover. Alright, in this general area here, there's a casting that goes in there. I'll show you the one on the other side. That guy right there. The front has somehow cracked off. I have no idea how that happened. Putting the engine back in this thing. This is an 836 now. Punched out from a 750. Let's get over to the mill, show you the philosophy on setting that part up and how I'm going to go about putting those lugs back on. I don't want to weld it. I know a lot of you guys are going to say, man, just build it up with a weld and grind it off with a file or something. Nope, not going to do that. I'm going to make a little stainless steel plug for it. It doesn't have to be stainless, but certainly don't want it to rust. So here we go. Well, imagine my surprise when I took the cross bolt out of this one, pulling the engine, and saw this mess here. That is just completely destroyed, and I have no idea how or when that happened because I've been riding that bike for years, but it has been sitting for a while. Back of the main foot peg has a yoke in it. It just simply goes down over top of that, and it keeps it from rotating, but with only one in position, there's a tremendous amount of play in that. Shouldn't be with the engine mount bolt tightened up, but I don't trust just one. Two is always better. So the plan here is to take the measurements that I need. The orientation, I want to make sure that the orientation is correct so the foot peg doesn't sag. I'll take the measurement heights, I'll take this, and hopefully I can just bore this thing off, make a pocket here, split it in half, make a plug that sits on top of it with a half protrusion on one side and a central protrusion on the other with a center hole. That's the plan. I'm going to hold this piece by clamping it down to a secondary chunk of aluminum. I'm going to drill a couple of holes in that, and now I have a nice block that I can squeeze in the vise for the machining here. I'm going to make sure that when this block is squeezed in the vise, I will turn the vise so that I can machine the step in the part true to the step on the repair lug. It'll make a lot of sense once you see it happening. All right, first step, map this out, put some screws in there, get this thing mounted in the machine. Prepping the fixture block is a no-brainer. Just use a 6-inch scale, go eyeball on the center to center, and use some studs that you know you can really bear down on. The half 13 threaded stud is very reliable, and it's the same size threaded stud that I use to hold the vise to the table, so I know it can take quite a load. The studs are considerably smaller than the holes that they'll be passing through, so you're going to need a washer or a plate or something on top. I keep a variety of these studs around just for clamping applications. Last minute surprise on the back two surfaces of this casting. The one closest to you, the one with the red dot stud coming through, there's a gap of about 1/16 of an inch under that stud right there, or under that casting. So the installation of a couple of shims was suggested where you risk cracking the casting or creating a feature that you're not completely happy with. Spinning the vise to align the broken section of the aluminum casting in line with the movement of the machine. Off camera, I squeezed parallels up against this and visually aligned this. Got to put the center of the machine over the center of the hole, using a gauge pin and an indicator to do that. Probably a little overkill, but wanted clean. Just so there isn't ka-thunk with the boring head, I removed the majority of the broken material with an end mill.
prior to moving on to the boring operation. Now using a boring head, I'm going to take that surface right there to the lowest point of the damage on the casting so no remnant fractures are present after the repair. It's spinning at about 1300 RPM for anyone that's interested, and that is a carbide tool, taking about 100 thousandths per side per pass. 2.5 millimeters-ish. Going to pull it off frame, measure the diameter so I know exactly the size of the plug that I need to make, and the final adjustment on the boring head so that the outside web of this feature is tinfoil thin when it's complete. I don't want to go too far. And that would be the final pass. And when I say tinfoil thin, you can see what I mean. It's also razor sharp, so do be careful if you ever do that. Use a piece of wood or a pencil or something. Don't do it with your fingers. Now, I did change my mind. So instead of cutting half of this away and having a half moon shaped cutout, because you would see it, I went to a 90-degree opposed key underneath the key that will be proud on top of the insert when I'm done. So this recess will accept a couple of ears on the part that I have yet to make and keep the whole thing from rotating. A little closer look at the pocket. Finished. Moving on to the stainless stud. This is also spinning at about 1200 RPM. And you'll notice that I'm taking almost a full depth of cut with this cutter, which isn't much. That's only 1/4 inch worth of projection. But if you were to take Z moves on this, if you were to move the cutter down into the part 20, 30, 40 thousandths at a time, you risk wearing the bottom of the end mill. And when you get to your final surface, you'll have a wear spot at the bottom of your vertical wall, equivalent to the incremental steps that you burdened that cutter with while you were making this wall. Using as much of the side of the cutter for doing an operation like that is always recommended. It just saves the integrity of the final feature tremendously. If you don't have a digital readout and you want to keep a feature like this true to the hole or true to the diameter, take the diameter and subtract the width of the final feature. So if it was a 1-inch diameter and a 500 final feature, you would have 500 as a remainder. Well, you want a half of that off of each side. So that's 250 off of each side. So realistically, the first thickness that you'll be targeting is 750, and the final feature that you'll be targeting will be 500. So when you cut the first side, look for a 750 dimension, and when you cut the second side, look for the 500 or the final feature width. And as I approach my final dimension, I will be raising the table. So watch the round part on the slug disappear on the final pass. Okay, if all went well, that particular slug should slide right down into the repair just made on the side cover for the Honda. So let's pop it out of here and check it out. All right, now to explain the blank that I started with, I knew the pocket diameter here when I bored the face to a specific diameter to wipe out the outside edge. So hopefully the plug itself will fit in there nicely and be relatively true to the front. I'll shine this up a little bit just to bluff it in, but you're going to see some deburring marks in there. The thickness of the groove cut in the end is the width of the key, and the length of the groove here, because I wanted it blind, I didn't want you to be able to see it from the front. The length of that is just a little bit longer than the diameter I turned on here, because the fadeaway should make up for the rounds in the corner. There we go. Ideal. All right. I like it. The alignment's good. The tangent is acceptable. And by making sure that the casting was set
90 degrees to the lug that was on there initially, I can now use this in the vise holding on this to establish the foot peg lugs that'll finish off this piece. A little better than it was. I like it. Now let's get back to the mill, put the foot peg notches on here and call it a day. I'm going to use a thing called an adjustable parallel to measure the gap inside the foot peg. As you slide these from side to side, they get bigger or smaller accordingly, right? Let's stick it in here. A nice seat. And you can see where some of the wiggle room has taken its toll on the casting, but we're going to go as tight as we can on that. And you simply take a measurement over the top. 592 and change. We're going to go 591 on the boss. And that should allow this thing to sit on there real nice. 591 coming up.
I am once again going to indicate the OD of this part so that the features are true to the hole. Last thing you want is the foot peg in one location and the engine mount bolt trying to come through and interfering with the foot peg casting. So closer the better. You can also do this with a pin in the drill chuck and line it up by eye if you have a pin that you feel you're pretty good with. The milling operation is being done exactly the same way as the first side, only I'm using the y-axis this time instead of the x-axis, and this feature is a little bit more meat on it than the other side. I will ultimately relieve some of the remnant rounds left on the end of these two flats, just so it blends with the foot peg a little bit better.
Okay, let's take a final look. Almost invisible. I'll take it. And the foot peg itself. On she goes. I would say that's a nice clean repair. If you didn't know it was there, you probably wouldn't pick up on it. Motion is absolutely minimal. You do not want this moving around very much because you've compromised the casting when you cut it away like that, so don't cut away too much. A simple lathe blank. Features 90 degrees apart, made it very easy to locate this part for final operations. And this is 303 stainless, guys. I got to correct something that I recently saw on the internet. Somebody's handing out the line of BS that 304 and 316 are easier to machine than 303. It is quite the opposite. If you have a chance, 303 is the way to go. It cuts like cold roll steel. You're really going to like the way it cuts. It's not as hard as 304 or 316, and it doesn't have the corrosion resistance 304 and 316 do. This is mildly, I mean, maybe 3% magnetic. If you were to stick a magnet up against this, you would feel some attraction, but it wouldn't hang on like, you know, a leaded steel or carbon steel. But 303 is the way to go. If you can stay away from 304 and 316, do so, because they surface harden, they work harden, and they're just a general bear. So whoever is handing out the advice that 303 is a terrible material, go back to school. 303 is an amazing material. All right, here we go. Thank you very much for tuning in. I am pleased with this repair. Wherever you are in the world, I hope you're well and happy and safe. This is Joe Pye, Advanced Innovations in Austin, Texas. I'm out.
There you go. After the installation, it is very clean and almost not noticeable at all. Realistically, you wouldn't know it was a repair if you didn't know what the original casting looked like. Very pleased with that.